Hello guys, today I'm presenting my solution to a challenge involving a current fetcher application, which is based in the hand software assessment task for the full stack developer position, utilizing C#.NET for the backend and Vue.js for the front end. The goal of the system is to periodically retrieve live current data, process it, and make it available for users to interact with the web interface. I'll walk you through the system design, the implementation approach, and decisions, along with the benefits with the solution. Let's take a look at the high-level overview, which is based on the system context diagram from the C4 model. At the core of the system is the current fetcher application, which interacts with the users right here. They access the application via front end to view and filter current data. Then we have this gray box, which is the current API. This is the source of live current data, which is fetched every 5 minutes. After this presentation, I'll change back to 1 hour fetching period, but for development purposes, it is fetching data every 5 minutes. I took some time trying to figure out the best API to do this task, which could not be an API too static and not a too complicated API. So this API was perfect for this application. And then we have two databases, one common database to store raw fetched current data, and a query database that stores processed queryable events from to ensure fast and user-friendly data access. So I decided to utilize CQRS pattern because I was unfamiliar with the pattern. I was not unfamiliar with the theoretic part of the pattern. I've studied before, of course, but I not utilize it in a reward scenario like that. So reading the specification, I understood and wanted to apply this knowledge. I knew that could be a little trickier than an orthodox approach, but I went for it. This separation of responsibilities from these two databases enables efficient data processing, scalability, and low latency user queries, which I will detail later. Of course, I did not any real modifications in the query database to improve performance for the query. So intrinsically they are the same, but semantically they are different. So let's take a look at the container view, which is the detailed design. The container diagram from the C4 model. To bring this system to life, I divided into well-defined components. Here are the components. Here at the top we have the front end, which I built with Vue.js and TypeScript as required in the challenge. The front end delivers the user experience by providing a filterable grid for current data and a table. Then we have the web API. So the front end sends requests and fetches data from the web API. It is written in ASP.NET, which serves the front end and interacts with the query database for querying processed data. Okay. Then we have the worker service right here at the left, a robust ASP.NET Core backend, which serves the front end. It is developed using .NET, and it not serves the front end. It is powered by the Hangfire. The service handles the critical job of, scheduling periodic data fetching tests from the CQRS API. So it interacts with the CQRS API directly, stores raw data into the common database, and then we have this query database updated. Of course, for simplicity purposes, here the data is flowing through from the common database to the query database directly, but we'll see in the next diagram that this is not true. We have a component right here in the middle. So it processes the events from the publisher and stores the event in the query database. So we have two databases. Again, we have the common database, which acts as the raw data store, and the query database, which stores preprocessed data for fast queries. This architecture right here embraces the CQRS pattern, where you can splitting responsibilities between data writing and data reading, which we can enhance performance and maintainability. Now let's focus on the component diagram. Here you have the worker service. Let's focus on it. Is highlighted here. First, we have the Hangfire scheduler, which triggers and fetch the data every 5 minutes. This will change after this presentation. It will be each hour. Then we have the data fetcher, which fetches raw CQRS data from the API. And then we have this important component, the event publisher, that is based in the MediaTR, a very well-known library in the C# ecosystem, that processes the fetched data and publishes it as events to the query database, not directly. We're going to have a different component right here that receives these events and processes these events, and then stores them in the query database. So these components interact seamlessly to ensure continuous and fault-tolerant operation. Let's take a look now at the development phase and decisions. This challenge was completed in about 8 hours of work, 4 hours of raw coding, which was based on setting up the project, implementing the backend, frontend, and database integration. I took 1 hour building the entire infrastructure, so configuring Hangfire, database connections, migrations, hosting, etc. 1 hour selecting the right CQRS API. So as already mentioned, the right API had to be accurate. So I had the right data being updated at the right time, not too complicated, not too easy. And 1 hour creating diagrams and this presentation. So revising and visualizing the architecture for better understanding and communication with you. And we have the design patterns utilizing in this application, which is CQRS, as already mentioned, the worker service pattern for periodic background tests, and the event streaming, which was utilized between the command and query database. Some benefits of this approach would be scalability, resilience, so the worker service and Hangfire jobs can retry failed operations. We have the user experience with our front end making queries from the query database, which ensures fast responses, and the maintainability with the coupled services and clear separation. This can be viewed in more detail in the code base. To conclude, I will demonstrate the application actions, showing how users can interact with it. So I look forward to answering any questions. So here you can see both applications running, the API running, and the worker running, and the web server, the web app running the port 5173. So here is the database. Here is the both databases. Here's the query database, and here is the common database. Last time they were updated was the time zone was wrong, but it was 5 and 20 was updated. So they are updating each 5 minutes. Let's take a look at the web server. The web server is running in the port 5173. So right now we can see that they already updated 8:25 p.m. This is the web application. The first query is a complete query, searching from all the base currencies and all target currencies. Right here you can filter. Let's choose euro, and we have all the target currencies for the euro. Let's choose the USD. Okay, now we can clean the filter and we can refresh it. So as you can see, we have the updated values right here in the screen. See ya.